On Capechi's Corner today, we're going to talk about the isosceles triangle theorems, and it's day 2, and we're going to look at some proofs. In looking at our first proof, we have some given information, and in the end, we're trying to prove that smaller triangle at the top, triangle ADE, is isosceles. So again, I need to come up with a plan. So I'm either going to need to show that the base angles are congruent somehow, or the sides are congruent, the legs, and go from there. So let's start with our given. Our first given says AB is congruent to AC. I'll mark the diagram. So I have AB is congruent to AC. Now from there, I've just shown that that big triangle, triangle ABC, is isosceles. So I can now say angle B is congruent to angle C. And we know that is true because of the isosceles triangle theorem. Remember, the isosceles triangle theorem tells us if two sides are congruent, then the angles opposite those sides are also congruent. So I'll mark my diagram. So I can't do anything else with that given statement, so I'm done with that. So let's look at what we have next. So I have angle B is congruent to angle 2, and I also have angle C is congruent to angle 1. That's given. Now I'm going to mark that diagram. B is congruent to 2, and C is congruent to 1. And so when I notice, because I marked it, I have a lot of congruency going on there. So my next statement, I know that I need to focus on that top triangle. So I do notice that angle 1 and angle 2 are congruent. So let's write that down. I notice that angle 1 and angle 2 are congruent, and that is because of substitution. Right? And that's steps 2 and 3. Steps 2 and 3. I said B and C are congruent angles, and then I said angle B is congruent to angle 2. And I know that angle C is congruent to angle 1. So in the end, I have 1 and 2 are going to be congruent. Now again, as I look at that top triangle, triangle ADE, I have angle 1 and angle 2 are congruent. So now I can say that segment AD is congruent to segment AE, and that is because of the converse of the isosceles triangle theorem. So converse of isosceles triangle theorem, which states if I have two angles are congruent, the sides opposite those angles are congruent. So now I'm going to mark that. Now from here I can say that triangle ADE is isosceles, and that is because of definition of isosceles triangle. The step before it, I identified that segment AD and AE are congruent, and that defines an isosceles triangle. And looking at my next proof, again, I have several triangles. I have a big triangle and 3 triangles kind of inside, so I need to figure out what I need to do. So let's start. I have segment BC is congruent to DC, so I'm going to mark that as my given. Now I have to look at where I'm trying to go. I'm trying to go that angle 1 is congruent to angle 2. Now I notice that angle 1 and 2 are not part of the same triangle, so I can't use isosceles triangle at that point. I might be able to use it earlier, but not at the end. And so again, if angle 1 is congruent to angle 2, the way I can get there is if I prove that those two triangles that they're in are congruent. So that's kind of my goal. If I can say triangle BCF is congruent to DCE, then I can say that angle 1 is congruent to angle 2. So that's going to be kind of my goal, to get those two triangles congruent. So I have segment BC and DC are congruent. That makes an isosceles triangle. So now because of that, I can say angle B is congruent to angle D, and that is because of the isosceles triangle theorem. So again, I'll mark that. B and D are congruent. I can't do much more with that given statement, so now I'll go to the next statement. Next given statement is segment BF is congruent to segment DE, and that's given. Now again, I'll mark my diagram, so I have a segment down here, segment down there that are congruent. Now again, my goal was to show congruency on this outside triangle, so I'm going to kind of color them so I can see what I'm looking at. And I do notice that I have triangles that are congruent, so I can say triangle BCF is congruent to triangle DCE, and that is going to be because of side, angle, side postulate. Right, the angle is between the two sides. And from there, I can say that angle 1 is congruent to angle 2, and that it's going to be because of CPCTC. Now, for our last proof for today, we have a pretty advanced diagram. We have a lot of segments going on there, a lot of angles. Now, in the end, I'm trying to prove that AE, this outside segment, is congruent to CD. Now, with that, I notice that those two segments are not part of the same triangle. So I can conclude that if I can come up with congruent triangles, if I can say triangle ABE is congruent to triangle CBD, then I can say those segments are congruent through CPCTC. So that's going to be my goal, try to get those outside triangles congruent. So now, again, I know whether I'm going to be dealing with isosceles triangles or congruent triangles. I know I'm definitely dealing with congruency. So for step 1, the measure of angle 7 is equal to measure of angle 8, which is a given. I'm also going to add that congruency part of that. And then I'm going to mark my diagram. Now, once I've said that, I can say that segment BE is congruent to segment BD, and that is going to be the converse of isosceles triangle theorem. Because I started with congruent angles, and I am concluding that the sides are congruent, that's the converse. Now, from there, I'm going to switch to the other given. So my next statement is going to be segment AB is congruent to segment BC, and that's given. Now again, I'll mark my diagram. So AB is congruent to BC. Now remember, we talked about the fact that we're trying to show that those outside triangles are congruent. So let's mark what we're trying to get to. So again, I'm trying to show that this triangle is congruent to this one over here. Put some color in it to maybe make it easier. So the next step I can have, I have two segments. I need to either come up with a third segment, which I know I'm not going to use because that's what I'm trying to prove, or an angle. And when I look at those two green triangles, I notice that angle 2 is congruent to angle 4, and that is because vertical angles are congruent. So I'm going to mark those angles congruent. 2 is congruent to 4. And then I'm going to go to my next step. Now I can say that those triangles are congruent. So I have triangle ABE is congruent to triangle CBD. And that is because I have side and an angle and a side. So that's side, angle, side postulate. So now once I have proven those triangles congruent, I can go to my last step. So I can say segment AE is congruent to segment CD, and that is because of CPCTC.